Okay, this is the first part of section 4.3, polynomial division, the remainder theorem, and the factor theorem. Okay, so we're really just going to focus right now on what we call synthetic division, which is a way that we can divide two polynomials. So I should really just demonstrate the process to help you understand what it is you have to do. Okay, the process looks odd at first, but you try it a couple times and you realize that it's really straightforward. It's really almost mechanical. You just kind of run through it really quickly. Okay, so let's do an example. X cubed minus 7x squared plus 13x plus 3 divided by x minus 2. Okay, so it's one polynomial divided by another polynomial. Okay, and it's really important that you set it up correctly. So the first thing I like to do is first recognize that x cubed is the leading term of the polynomial that is about to be divided. Okay, so I'm going to write out x cubed and then everything that normally comes after x cubed. Okay, so x squared, x, and then a constant, right? That's usually what you see. X cubed, x squared, x, and then a constant. Okay. Now I'm going to put the coefficients of each of these terms underneath. So this is an understood 1 in front of x cubed. So I'll put a 1 in front or under the x cubed. I'll put a negative 7 under the x squared, a 13 under the x, and then a 3 under the constant. Okay, I'm going to draw this line, skip one line, and there you go. Put this horizontal line here to indicate that I skipped a line. Okay, and so in this box right here off to the side, I'm going to put in the opposite of what I'm dividing by here, x minus 2. I'm going to put a positive 2. Okay, just a 2. No x, just 2. All right, now I have it all set up. Okay, some things to keep in mind. This number on the outside here is what I'm going to multiply all of my numbers down here with. Okay, they're going to multiply together. All right, I am going to start off by dropping down the first number. In this case, it's a 1. And like I said, I'm multiplying that 1 times 2. 2 times 1 is 2. That answer bounces up and to the right here. A positive 2. A positive 2. There we go. Now you see this is an addition problem, so you could just add them up. Negative 7 plus 2 is negative 5. Okay. Now again, here's 2 times negative 5. 2 times negative 5 is negative 10, so I'm going to bump that up and to the right. Negative 10. Okay, again, I'm adding these up. 13 plus negative 10, or 13 minus 10, is just 3. Okay, again, 2 times 3 is 6. So up and to the right, I'm going to put a 6, a positive 6. And 3 plus 6 is 9, positive 9. Okay, so now keep in mind when you're dividing, and I guess I don't need this right here, when you're dividing, think about as this x cubed will get divided by that x, right? Things get smaller. X cubed would become x squared. So your solution, your quotient, will not have an x cubed because we just divided that out. But it will have an x squared, an x, and a constant. And those 3 will always come from the first 3 numbers here, right? Or 4 or whatever, right? If you had more terms up here, of course, you would include more numbers. You will include all except for the last one. That last one is my remainder. So let me write that down. My remainder, I'll write it like a function. Remainder of x is equal to 9. That is my remainder. Okay, now what about the 1, negative 5, and 3? Oh yeah, that's part of my quotient. So 1, negative 5, and 3 will pair up with x squared, x, and constant to give me 1x squared minus 5x plus 3 as my constant. All right, you see how these all matched up. Okay, and of course, I'll usually leave that 1 off. Okay, so there we go. That's my quotient and my remainder. Let's do another example. Okay, and we'll see if we can do it a little bit quicker. Okay, here we have x to the 7th minus x to the 6th plus x to the 5th minus x to the 4th plus 2 divided by x plus 1. I feel like I'm missing a few terms there, right? You thought I was going to keep going, didn't you? Okay, that's why it's important that I jot this down. 7th, and what do I expect? X to the 6th, x to the 5th, x to the 4th, x to the 3rd, x squared, x constant, right? I expected to have these terms that were missing. Okay, so now when I'm writing the coefficients, right, I know there's a 1 in front of the x to the 7th power, right? I know this is an understood negative 1 in front of x to the 6th, a 1 in front of x to the 5th, a negative 1 in front of x to the 6th, or x to the 4th. I don't have an x to the 3rd, so I'll put a 0. And a 0 for x squared, a 0 for x, and a positive 2 for my constant, right? I want to make sure that I account for those. It's really important that I do. Okay, and then I will skip a line. And opposite of plus 1 is negative 1. So over here, I'm going to write negative 1. All right, that's the number I'm going to use to multiply. And yeah, let's see how we do. So we drop down the first number, 1. And then multiply. Negative 1 times 1 is negative 1. Up and to the right, negative 1. Negative 1 minus 1 is negative 2. Multiply those again, right? Negative 1 times negative 2 is a positive 2. 1 plus 2 is 3. Negative 1, now look at that. Negative 1 times 3 is negative 3. Negative 1 minus 3 is negative 4. Okay, I can't keep circling this, but negative 1 times negative 4 is a positive 4. 0 plus 4 is 4. Negative 1 times 4 is negative 4. 0 minus 4 is negative 4. Times that negative 1, that's a positive 4. 0 plus 4 is 4. Times that negative 1 is a negative 4. 2 minus 4 is negative 2. Okay, goodness. That was an example of a long problem, right? X to the 7th, that's a pretty long one. But notice it wasn't really that much more difficult. We just had to keep going, right? So quotient and remainder. All right, the remainder is always easy. It's that last number. So negative 2, you're the remainder. All right, what about the quotient? Remember, when you divide, that gets knocked down. So we don't have x to the 7th. We have x to the 6th, 5th, 4th, 3rd, 2nd, first power, and then the constant. And that's going to pair up with these numbers here. X to the 6th, that's 1x to the 6th, minus 2x to the 5th, plus 3x to the 4th, minus 4x cubed, plus 4x squared, minus 4x, plus 4. I think I did that right. All right, so there we go. That would be our quotient and remainder. Okay, again, that was a long problem. Let's do one not as long. Do one more of these before we go on to part 2. So here we have x to the 5th plus 32 divided by x plus 2. Looks small, right? Looks convenient, but I'm definitely missing some terms, right? X to the 5th, I'm definitely missing x to the 4th, x to the 3rd, x squared, x. I do have a constant. Okay, so what's in front of x to the 5th? Understood 1. I don't have an x to the 4th. I don't have an x to the 3rd. Don't have an x squared. Don't have an x, right? So all those are zeros. My constant is a positive 32. Skip one line, and then off to the side here, I'm going to put opposite of plus 2 is a minus 2. All right, let's see if we do this quickly. Bring down the 1. Times negative 2 is negative 2. 0 minus 2 is negative 2. Times the negative 2 is a positive 4. 0 plus 4 is 4. Times a negative 2 is negative 8. 0 minus 8 is negative 8. Times a negative 2 is a positive 16. 0 plus 16 is 16. Times a negative 2 is a negative 32. 32 minus 32 is 0. Aha, there we go. So that one has a remainder of 0. Okay, so that's the remainder. I can ignore that now. X to the 5th got knocked down, so I have an x to the 4th, 3rd, 2nd, first power, and a constant. Those correspond to these, of course. So 1 x to the 4th minus 2 x to the 3rd plus 4x squared minus 8x plus 16. There we go. That would be our quotient and remainder. Okay, and notice the remainder is 0. Okay, that's actually kind of important when dealing with the factor theorem and the remainder theorem. Okay, but we'll talk about that in the next part of section 4.3. So that's all for this first part.